In this video, we'll take a look at some of the ways that we can kind of polish off our tentacles setup. Now, before we do that, I just want to point out that I've gone through all of my OTLs and added an output tab by just promoting some parameters off of the geometry IO OTL that we created. And an interesting thing about this is that I made, for each of these preliminary OTLs before I get down to the render one, the frame range is actually set to, by default, $f_start -1 to $f_end +1. So in other words, we're adding a frame to the beginning and the end of the frame range. And the reason why we're doing that is because when we get down here to the render node, I'll just go inside to render settings. You can see there is a trail stop here, and the trail stop actually requires a frame, well, for the backwards difference velocity that I'm doing, the trail stop requires a frame before frame 1 in order to do that computation, otherwise it's going to error. So what I've done is for all of the nodes before the trail stop, I'm adding a frame to the beginning and the end. And then for the node that has the trail stop in it, I'm just rendering the actual frame range. And that way we'll have what we need in order to render. Let's go ahead and match current definition. Now you might be wondering, if I'm doing backwards difference velocity, why do I have a frame on the end as well? And that's really just force of habit, because I work at a place that does center of frame motion blur. And in order to compute that, it needs a frame both before and after in order to figure out what the motion blur should be. Another thing to notice is that our setup is starting to get a little bit complicated. So if you imagine as a user going into a new shot and being like, okay, I want to do tentacles, now you have to either remember what the OTLs are and put them down in order and wire them all up and create your own ROPNet with your own mantra node inside, and then add some volume thing, which I've just added in here so that when we render it'll look like it's underwater. That's a bit much to expect, so probably what most people will do is just copy paste the nodes from hip file to hip file, which, if you remember, one of the reasons why we're using OTLs in the first place is so that people don't have to do that. Really, we would prefer that someone just go ahead and open up their scene and maybe grab their camera and their lights, depending on how you do that at the studio you work at, and then just find something in the tab menu, and it would just make their setup available to them. And if you remember, we said that there are two general ways that people make setups in Houdini, and one of them is just to create a single gigantic OTL with lots of tabs and parameters on it. And that's something that would actually be simpler about that, is that they could just drop down the one OTL. Fortunately, even though we're using this approach where we have a whole bunch of OTLs, we can still get around the fact that it's hard to instantiate it. That's what we're going to look at first. So the way this is going to work is we're going to take all these OTLs and just drop them into another OTL that contains all of them. So let's just go ahead and do that now. We're going to go ahead and select all of the nodes in our setup. And I'm not going to consider my camera or my lights as part of my setup, because, as we said before, we're expecting people to be able to instantiate those themselves in their shot. So I'm just going to select all the nodes that are actually part of my setup and hit Shift-C to drop them into a subnet. And then let's just go ahead and create our digital asset. And as usual, I'll just save it someplace that makes sense. Okay, and hit accept. And it's just warning me that my setup is referencing some geometry outside of the setup itself, which we're just going to go ahead and ignore for now. And since we'll be hitting apply and accept quite often, we're going to be dismissing that dialog quite often as well. Okay, so we did say that we weren't going to do the giant OTL approach in this class. So what we don't want to do is just step back into that purely because we want people to be able to instantiate our setup easily. So we're not going to be going and promoting all of the parameters from each OTL that we created and putting it on this interface. Now, there is a way that we could do this, which is sort of like a compromise between the two approaches, where we just have this setup OTL and we put a few parameters up here that we think are common to all setups. all tentacle setups, that is. And so that would be something like render all button, where it will just render all of the geometry in sequence, for example. And that can be useful, but for this particular case, I want to look at what if we actually want people to use these nodes. So for example, we want them to come inside and start modifying things, and we don't want to risk them breaking whatever buttons we create. So in that case, what we can do is create what we call a self-extracting OTL. And basically the idea is that this OTL that contains our setup, when we put it down, it's going to just copy all of the nodes inside out to the outside, and it's going to just delete itself. And we can do that using a Python function called extract and delete, which is just available on our node object. So let's look at how that works. The first thing I want to do is go to the scripts tab here. And if you recall, we can just create an uncreated script here, which maybe our first instinct is to look here for where to put that extract and delete thing. So we're just going to put down our OTL, and then it's going to extract and delete itself, and that'll be all good. There is one worry with working this way, though, which is that in order to modify this OTL, we do have to be able to instantiate it so that we can do things like bringing up the type properties dialog and changing the nodes inside. So what we need is some mechanism to tell Houdini, hey, normally when our user puts down the OTL, we want you to extract it. But when we put down the OTL, we're going to do something special that says don't extract it so that we can work on it. Normally the way that Houdini does stuff like this is by holding down the control key and clicking on the tool that we're invoking. So let's just see if we can do that from the uncreated script. Normally that information is available in kwargs, so let's just double check what we have available there. We're going to print kwargs in here and hit apply. And let's just put down our setup node. And notice that we have our node, which is great. That's what we need in order to call the extract and delete function. And we have a node type, which is useless to us in this case. We do not have information about whether or not the user held the control key when they invoked the tool. So this means that if we want to make it easy for us to drop down an instance of the OTL itself, we're not going to be able to use the uncreated script for that. Now we will need the uncreated script for something else, but for now we're just going to go ahead and delete it. What we will want to do is go over here to the Tools tab. And this tab just lets us control how Houdini sees the tool that we're trying to invoke. And this is sort of a generic interface. You'll notice that it looks awfully similar to the interface we use to create shelf tools. So we have all of these various things like labels, which is what will show up as in the tab menu, and the name of the tool and things of that sort. And we can control what context it's invoked in and even give it a hotkey if we want. For now, we're just going to modify the script that gets run when the user clicks on the item in the tab menu. Now notice that Houdini has put in some code here automatically. And the way this works is it's importing this module called object tool utils, which is just a Python module that's shipped with Houdini. And then off of object tool utils, it's calling this generic tool function, which is the thing that actually creates the node. And then that just needs this information in order to create the node. So what I'm going to do is I'm just going to see what is in this kwargs dictionary for now. So let's just go ahead and print kwargs and hit apply and see how this works. And delete that one, and let's just create another setup node. Bunk. And notice that because I put my print statement before the generic tool, I'm still sitting here floating on where to put the node down, and it's already printed out the kwargs. So we can already see that we can do things before and after the tool is actually put down. So I'm going to just put it down. And let's look at what we have. Now we have a whole bunch of information, most of which is outside the scope of this class, but notice that we do have our control click. What we don't have is our node. And we do kind of need that. If we're going to extract and delete the node, we need to have a variable that allows us to get to the node that it just created. So what we want to do is just say, hey, this generic tool is creating the node. It's going to return the node, so we can just drop the node into a variable like so. And I'm going to go ahead and delete my print createDebugArgs statement, clear my console, and close it. All right, so what we want to do is we want to say if the user didn't control click, we're going to do a bunch of extra stuff after the node was created. So let's do if not createDebugArgs ctrl click node.extract and delete. And we'll hit apply. And let's see how that works. So I'm going to delete that. I'm going to say setup. And if I go ahead and just drop it down normally, our OTL disappears, and it's just as if we put down all of these nodes all at once. So that's pretty cool. And then if we go ahead and do setup and control click on it, you can see that we have our OTL here and it's ready to be modified. So I'm just going to go ahead and delete that. And there's something that's kind of neat about this. I'm just going to shake that off, put it over here, which is that if we invoke the setup by right-clicking on the output for our camera, which is the thing that we need to have as the input to our setup, right? We can say tentacles setup. And because of how extract and delete works, and because our emitter was plugged into the first input of our setup, we can see that here, it's plugged into the first input of our setup. Our emitter just automatically gets plugged into the camera. So it really feels like we're putting down this whole setup as like how we would be putting down a single node, which is pretty neat. And it's all kind of ready to go and wired together, and the user can just start working. Now, something that's a little bit annoying about this is we mentioned that it's referencing collision objects from outside the setup. So it would be kind of neat if when we put down our setup, we could have it automatically fill in these collision fields. Because it's a little bit annoying for the user to have to go in every single time they are doing a new shot, to have to just fill in these fields automatically, especially if they aren't super familiar with the setup. It'd be nice if it just did that for them. So I'm just going to, by default, I'm going to clear these, but of course I can't do it here because this isn't part of my setup node. So I'm going to go ahead and delete all of these. And then we can use our fancy control click mechanism to put the OTL back down so that we can modify it. So let's just do setup and control click on that, and it puts it down. I'm going to allow editing of contents and go inside. We're going to go to stick to collisions, and we're just going to clear this collision object so that by default, it's just 0. Then let's come back out and save node type, match current definition. All right, so how do we go about automatically filling in those collision parameters? Well, the way that we can do that, there's a couple of different things that we could do. Probably the simplest approach is to just ask the user to select them in the viewport. So that's what we're going to do. Now, how do we ask the user to select things in the viewport? I'm just going to go ahead and dismiss the type properties dialog for now, and we're going to just look at it through the Python shell. So I hit Alt-Shift-P to bring up my Python shell. And the way this works is there's a function in the module toolutils. So I'll just do import toolutils. And this is just another one of those modules that ships with Houdini. And the function that we're after is called toolutils.sceneViewer. And what this function does is just return an object that represents sort of like whatever scene viewer is actually active. Now, note that this is a little bit different from a viewport, and that's just kind of how the Python objects are structured. So we're going to say, I'm just going to dump the scene viewer into a variable. So we'll just say something like scene underscore viewer equals toolutils.sceneViewer. And now all we have to do is say scene viewer dot, and we can see there's a bunch of different things that we can do in here. The one that we're interested in is select objects. And notice that we have a whole bunch of different options here, and I would encourage you to go and explore what these do on your own. But for now, we're just going to go ahead and set a prompt, which is nice and easy. So we're going to say prompt equals select collision objects. And if I hit enter, you'll notice that it paused my Python shell, meaning that whatever Python script is running is going to stop and wait for the user to select some objects. So I'm going to just go ahead and select my terrain and my submarine. And then you'll notice that my nice prompt here for select collision objects is down here at the bottom of the viewport. And I'll just hit enter. And now my Python script has been released, and it returned a tuple containing the two nodes that I just selected. All right, so this is all well and good. Let's go ahead and add it to our OTL. So I'm just going to allow adding of contents for now. Go to type properties, and let's figure out where to put this. Now, unfortunately, if you try to invoke these select objects functions from the tool script, Houdini won't actually let us freeze the script and wait for the user to select the objects. So we're going to have to do that from the onCreated script. So let's go back to the scripts tab and add our onCreated script. And what's interesting about this is that the onCreated script is going to get run when the node is actually created. So what's going to happen is, if we go back to our Tools tab for a second, Houdini is going to go ahead and import our object tool utils, and then it's going to do object tool utils.generic tool. That is going to run our onCreated script, so whatever we put in here. And then we're going to come back over here to the Tools tab to run whatever comes after the generic tool function. So what this means is that we can use the onCreated script to add things that happen before the extract and delete if we want to. And we do. We very much want to. So let's go ahead and just copy our code across, because we want to, in the onCreated script, we want to just have it prompt the user to select collision objects. And notice that this function is returning a list of the objects that we selected, so we want to drop those into a variable. Now what we want to do is we want to set our collision node, and I don't need my Python shell anymore, so I'm just going to go ahead and dismiss it. On our collision node, we want to first set our multiparm block to the number of collision objects. So that's a parameter called number of objects. And first we're going to need to get this node in the first place. So the cool thing about this is that since we're doing the extract and delete, we're never actually giving our user a chance to go in and mess with our setup and break any of our Python scripts. So that means that we can actually just go ahead and use hard-coded references to node names without worrying about the user breaking things. So I'm just going to go ahead and copy the name of the stick to collisions OTL in my setup node. And let's just go ahead and get that one. So I'm going to say collision object equals, and this is just going to be a child of the current instance that's being created. So we know that that is going to be kwargs node, and we can just say dot node, and then paste the name that I copied out of the network editor there. Now that we have the collision object, and in fact, I'm going to call it collision node, because that makes more sense. Now we can just say collision node dot parm number of objects dot set, and we're just going to set it to the size of our collision objects list, and we can just find that by saying len collision objects. So if we select the terrain and the submarine, collision objects is going to contain 2 elements. So len collision objects is going to return 2. So we're just going to set our number of objects parm, which is right here, to 2. Let's just hit apply to save all the code. And I'm just going to go ahead and set this to 2 so that we can see the parameters that are going to be created as a result of changing this parameter's value. These are called collision underscore object underscore 1 and 2. So what we're going to need to do is do a loop over our collision objects, and we're going to need to set these parameters. And there's a couple of wrinkles to this. The first is that Python for loops are, by default, they just want to loop over a list, and inside the loop, you just have access to the current element that you're looping over. Unfortunately, that's going to be a node object and not an index number. So we'll need some way of getting access to the 1 and the 2. And then the other wrinkle is that, of course, we're starting at 1, and usually in Python, it expects us to start at 0. So we're going to need to deal with that as well. So let's just start with our basic for loop. So let's go down here and say for collision object in collision objects. And we'll just go ahead and set these parameters. So we're going to say collision node.parm collision object underscore, I'm just going to give it a format string, and we'll say dot format. And here's where we're going to need some number which represents the iteration number of our loop. So I'm just going to say idx for now. This is a variable that does not exist. We're going to be creating it later. And I'm just going to finish out this line so that we can talk about how to create that idx variable. So this should give me, assuming that I can get an index for whatever my loop number is, this should give me a parameter which corresponds to one of these, depending on how far I am through the loop. So when I'm looping, so ideally, when I'm looping over the first object, it'll give me this parameter, and when I'm looping over the second object, it'll give me this parameter. Now, if we recall, we said that we need to deal with the fact that we start at 1 instead of at 0. Python's going to want to start at 0, so we're just going to add 1 to our index. And that's going to make us start at 1 and then go to 2 when we hit our second object that we're iterating over. And let's just expand this out a bit so that we have plenty of space. And then we can just say, now that we have that parm, we're going to just set it to our current collision objects path. All right, so how do we go ahead and create this index variable? The way that we can do that is with the Python enumerate function. So we're just going to say enumerate collision objects. And basically what this does is it returns a list of tuples where the first element in each tuple is the iteration number and the second element is the actual object that we want. Creating a special Python object that we can then use with a for loop if we just say idx, comma, and then the variable that we want to store the actual object in. All right, so now we have our nice for loop. I can hit apply. And let's see if it works. I'm going to go ahead and hit accept to dismiss this dialog. And let's try putting down our setup. So setup. And now it waits so that we can select our collision objects. I'm going to select my terrain and my submarine. And then just hit enter. And of course we get a permission error. So why are we getting a permission error? Well, the problem is that when we're instantiating a new OTL, you can see that it went ahead and did the extract and delete because it continued running the tool script. So when we're first instantiating this OTL, of course, it's going to be locked. So if we're going to try to modify parameters inside it, we're not going to be able to. So there's a couple of different ways we can get around that. If we go back to our type properties, the simplest way is we can just go to the Save tab, and say don't save contents as locked. Hit apply. You'll notice that the lock icon was completely removed, which to me looks a little bit scary, because what's happened here is that if I dive inside, notice that nothing is locked anymore. So this OTL is essentially permanently unlocked. This is a setting that's intended for OTLs just like this, where they're either self-extracting or the user is intended to go in and change everything inside. And as the creator of the OTL, we really do not care what's inside the OTL at all. I highly recommend against doing this if you are creating any kind of setup where you depend on things like node names and the way that things are wired together for the parent OTL itself. And really, if you have to ask, the answer is only do it for self-extracting OTLs, unless you know what you're doing. Kind of the wrinkle to this is, you'll notice if I right-click, there's no save node type anymore. And the reason for that is because Houdini's like, well, it's not that kind of OTL anymore. But the problem is that you might want to be able to change defaults. So in other words, you want to be able to go in here and say, hey, this is, by default, we're going to have a different seed on the thickness or a different amplitude on the noise that's going into the shape of the tentacles. In order to do that and have it be saved for when the user puts down a new version of this OTL, you can just bring up the type properties dialog and hit apply, and it'll just save it. Now this is kind of an advanced way of working with OTLs, so if you're worried about how this is all working and you're kind of getting confused, just go ahead and leave save contents as locked, and hit apply. And then under our scripts tab, in our onCreated script, as soon as we get the collision node, we'll just go ahead and unlock it and say collision node.allow editing of contents. And that'll solve our permissions error just as well. All right, so let's go ahead and try it out. If we do setup, and of course, I'm going to need to dismiss this type properties dialog. Let's go ahead and put down our setup. It waits for me to select collision objects. Of course, we need to say kwrgs node.allow editing of contents. So all you have to do is just say kwrgs node.allow editing of contents, and that will solve it just as well. So we'll just hit apply. And in fact, I'm just going to hit accept to dismiss the dialog. And let's try it out and see if it works. So put down our tentacles setup. It's going to pause and ask us to select our collision objects, which I'm going to do. And we are in business, it seems like. At least we didn't get any errors this time. Let's go look at our collisions OTL and see if it worked. And there's the two objects that we selected. Now, there's also the pesky matter of the fact that our mantra node is hard-coded to look at a particular camera. So you might be wondering, well, do we just have to select modes? So first you select collision objects and then you select a camera? And I guess that would work. It just seems a little bit annoying to have the user be like, oh, I want to put down a setup. And then it goes through a whole bunch of prompts for them to select things. So what might be a slightly better solution is if we go into our setup node and we just say, well, we have to plug the camera into our emitter node, and we know it's going to be plugged directly in, or else the emitter node doesn't work, right? Because the emitter node is going to be grabbing things from the camera. So what we can do is we can say, well, we know that our emitter node is probably going to be plugged into our camera. So what we can do is just say, okay, I'm going to grab whatever my emitter node is named, and I'm just going to do an expression and say in my mantra node, op input path, we're going to give it the emitter node. So that's going to be ... and then paste the name of the emitter, which I copied before. And then that's just going to be the emitter's 0 input. And for now, that's nothing, but we can just test if it's working by plugging our setup node into, say, the tent 0001 camera. And indeed, we get a valid camera for our mantra node. So what that means is that if I go ahead and save node type on my setup, and let's just go ahead and delete all these nodes, and I'm going to just disconnect this one and move it over. I'm going to get rid of this as well so that we can just say, okay, we have a new shot. Here's our tent 0001 camera. We're going to right click on the output of the camera and say setup. And it's going to ask us for our collision objects. So we're just going to go ahead and select them and hit enter. And now we automatically have a valid expression set up to pick up our camera without having to do anything. And this has the added benefit of if we do want to put down some other camera, like maybe a different camera is published for our shot, and we want to keep this one around for some reason, all we have to do to make it work is just reconnect this emitter node. So if we reconnect it to tent 0002, and of course our mantra node is going to update automatically, and we don't even have to worry about it. In this video, we looked at a way to polish our setup by making it easy to instantiate in other shots.